Here's what's coming today on the Woodworking Network podcast.
We give ourselves one day. Right? When we arrive at a manufacturer's and we have to deploy an automated sanding solution, we need one day to unpack the machine, assemble it, configure it, and get to sanding.
Welcome to this episode of the Woodworking Network podcast. Join us as we explore the business of woodworking, big and small, and what it takes to succeed. I'm Will Sampson. Today's episode is sponsored by FDMC Magazine. Today my guests are Etienne Lacroix, CEO and founder of Vention, and Nick Ork, technical manager for 3M's Abrasive Systems Division. We'll be talking about new developments in robotic sanding and what it means for woodworking businesses, particularly smaller operations. But first, I want to talk about, are disruptors good or bad? Once upon a time, a disruptor or disruption was a bad thing. Remember when you got sent to the principal's office for disrupting class? But these days it seems everybody wants to be the next disruptor. And that's seen as a good thing. I'm confused. It must go back to the old expression, you can't make an omelet without breaking a few eggs. The idea is that progress rarely happens without something or somebody getting hurt. Still, the end is seen as justifying whatever it took to get there. Take a look at how it works inside your business. You probably don't naturally embrace disruptions in your business. You want things to run smoothly and efficiently. But if you continue to do everything the same way you have always done it, you are likely to have competitors speed right by you. That's disruptive too. No one can just stand still in business. Companies that adopt principles of continuous improvement try to institutionalize internal disruptions to keep the upheaval to a minimum and maximize progress at the same time. That's easier said than done, but companies that embrace a culture of continuous improvement learn quickly that they are also embracing to some degree a culture of chaos. Maybe it's mostly controlled chaos, but chaos nonetheless. From the outside, business disruptors are basically looking to profit from what amounts to a scorched earth policy. They want to create a new business model that does away with competing older business models. Obviously, they're more focused on the profit to be gained by their disruptive idea than the potential damage it might do to pre-existing models. The goal is to create a new paradigm and never look back. Successful disruptors are heralded as business heroes and compete with pop stars for the top slots on celebrity A-lists. I've been on both sides of the disruptive way of life. I lived in Silicon Valley when Steve Jobs and Steve Wozniak were driving around their first Porsches in the early days of Apple. I bought machinery and equipment for my first small manufacturing business from an engineering student at Stanford who later built the first Apple mouse prototype. It was an exciting time, but it also was very disruptive for businesses and whole industries that could not keep up with the change. Today's economic upheaval is like that, but much faster. Disruptions happen before you know it. Then you have to deal with the consequences. But by then it might be too late. The current business climate is like surfing. You've got to stay out in front of the wave or the wave will take you under. Standing still or waiting on the sidelines is not an option. You can take time to worry about being sent to the principal's office for disruptive behavior. You need to constantly move forward to stay ahead of the disruptions that could overwhelm you and your business. Now for a word from our sponsor. FDMC Magazine is your vital source of information to improve your woodworking business, whether it's keeping you apprised of the latest advances in manufacturing, helping you improve efficiency with lean manufacturing guru Brad Cairns, or inspiring you with case histories about successful businesses and best practices. FDMC Magazine is there to be the sharpest business tool in your shop. Learn more and subscribe for free at woodworkingnetwork.com/FDMC. Now let's talk with Etienne and Nick. Today, my guests are Etienne Lacroix, CEO and founder of Vention, and Nick Ork, technical manager for 3M's Abrasive Systems division. And we'll be talking about new developments in robotic sanding and what that means for woodworking businesses. Welcome to the Woodworking Network podcast, gentlemen.
Thank you.
Thanks for having us.
No problem. I think I want to start out sort of at the beginning. Why should a shop consider robotic sanding?
Well, I can take a shot at it to start.
This is Nick.
This is Nick. So, robots, when they're implemented effectively, can replace human labor that's increasingly difficult to find, to train, and to keep. So that's one of the major factors right there. But there's many things that go beyond that. You can actually increase your capacity or throughput with a robotic system because robots can apply abrasives in more optimal ways than a person can over the course of their workday. So you can increase that productivity and throughput. Robots, they also repeat what they're taught very well. So when taught correctly, they can improve your quality and consistency of your output if that's an issue. And typically, your abrasive costs can go down because the robot is able to use that abrasive product more completely and effectively. So fewer pieces are required to get the job done.
Interesting. I hadn't thought about the abrasive angle. That's definitely significant.
And perhaps I can put that in the case of a client situation for the very reason that Mark has described the challenges of finding that labor and training them, which take months to train a human to do sanding properly. And it's a job that is very hard to retain. What we see when we replace or when we bring in robotic sanding is operator can often be reallocated. We've seen ourselves at the Fabrida, which is one of the case study we might talk about a little bit today. They went from 4 people doing manual sanding to 2 supervising 2 robots, which is, those are the type of great success stories. So they saw throughput increase by roughly 30% by putting those solutions in place. So you get the best of both worlds. You get throughput increases, and you also have the ability to reallocate labor that is so hard to find, especially in the woodworking industry.
Well, and the robot shows up on time and
Exactly. Aren't taking coffee breaks.
So are there particular kinds of things that a robot is, you mentioned having both robots and human folks doing sanding. What are the kinds of things that are best for a robot to handle?
What we've seen, and my apology, Nick, I mispronounced your name initially, but what we see mostly is veneer, MDF, softwood, plywoods. They're all being used, and they can be sanded, again, with that consistency that is so hard to achieve with human labor. So we see a wide variety. In the deployment that we've done in technology we've developed with 3M so far, it was heavily focused on cabinet makers, mostly kitchen cabinet makers, so heavily MDF oriented, but we see a wide variety.
So we're talking mostly about flat surfaces, or are we doing profiles too, or
We a lot of flat surfaces, but very often, if you look, for example, at a shaker door, you will have requirement to sand the inside and the outside of the panel, and being able to have an automated solution that can detect those patterns and decide how to send them without needing a prescriptive, human input is the key. So, today, I would say sanding is an application where you can do autonomous robotic pretty well, which means the equipment are very easy to operate for the manufacturers. You can completely fill a sanding table out of various door patterns, the small, large, and so on, and let the robot figure it out. The robot will survey the panel in front of them, define their own dimension, define if there's a shaker pattern or not to be sanded, and will go apply the properly defined sanding trajectories in those areas. So it's a very autonomous system that can be done, which means less operator intervention and greater ROI for cabinet makers.
So the robot
Yeah.
can do things like breaking edges and that sort of stuff too, or is that something that's better for the human to do?
Yeah, all of this can now be configured because the robot now has the ability to detect all those change of surfaces, change of plane, and then you can apply a prescriptive recipe to it. And I think that was one of the great things working with 3M is bringing all the craftsmanship and the expertise they developed over the years and inject that into prescriptive path planning for the robot. So you get to that craftsmanship, that level of quality repeatedly. And I think that was part of the product we had a chance to develop with 3M is that union of craftsmanship and expertise with the robotic technology combined.
How difficult is it to set up and program a robotic sander? You're talking about these sanders that are scanning the stuff themselves and all. What are the challenges of going from a human operated sanding system to robotic sanding?
I can give some past experience in that. In the early 90s, I began my career in the abrasives organization at 3M, actually programming robots to do abrasive applications. And at that time, we were doing a lot of teach pendant programming, which is essentially creating a dot-to-dot matrix of the surface that you want to follow with the right abrasive processes, parameters. And that really requires a lot of understanding of robot programming technology, of the abrasive technology and the like. And that's very difficult to learn and obtain and develop that skilled labor. And now with the current scanning and planning techniques like are being used with Vention's model, the scanning process identifies what needs to be sanded. The software develops the robot path and the pre-selected parameters that can be adjusted really to tweak the outcomes, make programming so much easier for any level of operator or employee. Takes from expertise down to something that's almost entry level.
Correct. We give ourselves one day. Right? When we arrive at a manufacturer's and we have to deploy an automated sending solution, we need one day to unpack the machine, assemble it, configure it, and get to sending. And the reason it's so quick is because in the world of automation, we call that it's a loose coupling machine. Most industrial equipment required a hard coupling with the other manufacturing asset. I need to talk to a PLC, I need to talk to the ERP, I need to talk to other sensors that are perhaps upstream of the machine, and that makes deployment quite complex and more service intensive. The world of sending, the only coupling is the input signal coming from the panel shape or the panel dimension. Those machines are rarely connected to other equipment inside the plant. They're autonomous by themselves. So you assemble the machine, you power it on, and you're ready to configure your first panel. And so it's a quite of an easy deployment. And in all the machine we deployed here at Vention, it's around 1,000 to 2,000 equipment per year. Those are probably some of the easiest to deploy because of that loose coupling with the existing asset.
Interesting. Now, what about when you talked about having both human sanding and robot sanding? Are these, well, I guess what they call cobots that are safe around humans, or do you have them in a protected area, or how does that usually work?
There's both type. In the context of the collaboration we've done with 3M, we've worked mostly on a very operator-friendly and safe autonomous robot cell. So the robot is collaborative, it works at collaborative speed, and therefore doesn't need to be guarded. And the robot even talks to the operator when the abrasive is due to be replaced. It just presents itself, so it's easy for the operator to remove the pad and put a new one. So all those little things that really facilitate human-robot interaction. That said, we see a high throughput system where even the in-feed of the panels are automated, the outfeed are automated, and we've done those dual robot arms sending at the same time. Those are usually for higher throughput. They are fully guarded. There's a more complex safety chain to make sure we respect all the plant health and safety protocol. But so there's a range. The vast majority are the friendly, collaboration with the human operator, but we see those more high throughput systems that are fully guarded as well.
Yeah, I think that's one of the elements that we try to preach from 3M's perspective is we have to make sure that safety is paramount whenever we're operating a robot with an abrasive tool, whether it's collaborative or through a more industrial robot type system. The robot may be collaborative, but the tool on the end of that robot may not be collaborative and may not stop or whatever. You could envision putting a knife or some other kind of a sharp object on the end of a collaborative robot that's moving it around, and it still has the ability to damage or injure a person. So we have to make sure that that safety is paramount as we're looking at that in terms of guarding or other processes to make sure that the operator or the person that is loading the cell is not within that working envelope. But that being said, the vention systems seem to be managing that quite effectively.
Now, are Nick, are the abrasive requirements any different than for sanding with hand operated machines, or is it just it's on a robot arm instead of a human's arm?
Well, in general, there aren't a ton of differences in the abrasives or the abrasive formats. We may take a different approach depending upon the type of method or application that we're working on. But for the vention application for cabinet sanding, we're using the same approach of tooling, random orbital sanding, to do the job of the abrading process. Where we get into abrasive differences are just in the ability of the robot to apply higher forces and operate at faster rates, so we can take advantage of more advanced abrasives. So you want to take advantage of your productivity gain that you can get with the robot. So if it's able to remove faster, we want to be able to use a tool that can do that removal in a faster state. We also want to think about the abrasive life. You want to spend as much time on the surface of your workpiece doing the sanding and very little time stopped waiting for abrasive change. So whenever that robot's not on the surface, it's not doing work. So therefore, having long-lasting abrasives becomes important. If I've got a product that lasts 3 times longer, I stop 3 times less often to change that product and have it idle.
Now, are the changes, I was just curious, the changes like for grits and things like that, are those have to be handled manually by an operator, or is there a system for, like on a CNC machine, we have automatic tool changers. Is there's something like that for the robots?
There are automated disc changing and tool changing devices for a variety of robotic applications. For something that might be more basic and simple, where the operator is loading the panels, it might be just as easy for the operator to change the disc when it's alerted that the disc is completely used. So it really depends upon the complexity of the machine and the tool and the process in front of the customer. I think one of the things that's quite interesting about the 3M products is we've incorporated some of our own proprietary mineral and shaped grain products that enhance the use of abrasives in robotic applications. So we're able to cut things faster, have the abrasive products and articles last longer, or provide more consistent finishes. So it all enables a greater ROI on robotic systems.
And what's interesting is when you couple that kind of abrasive performance with a robot program that understands completely how much life has been used for the abrasive, you can proactively tell the operator it's time to replace now, right? And therefore you end up always having that consistent quality because you don't end up sending where you're no longer supposed to be after that extended life. So again, just another little things that robotics application enable to improve in terms of additional quality.
So like after a certain number of doors or a certain time or whatever, it's time to replace the
robot would present itself in a friendly position, so the operator only have to remove the pad and put another one, right? So it's all automated based on how much surfaces has been sanded already by the application.
Yeah, that's the abrasive change is a element that most manual operators don't even consider as a priority when moving to robotic applications because the task is so simple by a human. When that abrasive feels like it's not cutting anymore, the operator can remove the disc and replace it with a new one in a matter of seconds, and they're back to their job. When either the disc has to be changed by a person or automatically, that robot has to go to a position in which it is preparing itself to be changed. And if that operator that changes the disc is actually doing another task, they may not get back to changing the disc for a couple of minutes where it's sitting idle. So even though it's an easy task, having a longer lasting product that requires the change less often reduces that impact greatly. So it's a much, much bigger consideration than for manual operations.
Well, in my experience too with manual operators, and correct me if I'm wrong, but I think there's a tendency of using the abrasive material longer than you probably ought to.
Well, in my experience, they actually use it probably less than
Oh,
they
really?
possibly
That's
could. They want to
interesting.
use it while it's sharp and it's most effective. And as it dulls out a little bit, they want to keep their productivity up and they want to keep their job as easy as possible. So they may actually change out the discs more often than they need to. With a robot, you can tell it how much force to use. You can tell it how fast to do the job and use the product effectively and get more complete use out of that disc than you would most often with a human operator.
Now, I think a lot of our folks in our audience have the preconceived notion that robots are only for big, huge production facilities, but we are seeing them showing up in smaller operations. What's the situation for what Vention is offering? Is this something that works for smaller operations as well as big plants?
Yeah. So we, Innovation as a company, our main mission is to make industrial automation accessible to small, medium businesses. We primarily serve small, medium manufacturers that have high production mix and high SKU mix. So we usually develop products and application with those constraints in mind. The robotic sanding application that we have, I think, goes around 150,000. So as soon as you have two operator, for example, on a 2-shift, you will get very close to this 1 year payback, which is usually the magic number for a cabinet makers, right? If we can get a system roughly within the year's financial budget and be fully paid back by the end of the same fiscal year, usually those investments are more attractive to small businesses. And we're getting to those price point today where you can afford to have fully robotic cells working, 1 or 2 shifts a day with that level of payback.
Wow, that's impressive. Now, what's the process that Vention uses? I gather that Vention has a sort of a different business model and how they deal with automation systems and all. Can you walk us through how that works?
I'm sure, maybe some of the audience are familiar with what I call traditional industrial automation, but I like to say there's nothing more manual than industrial automation because the act of putting those systems together with the robot manufacturers, the N of R manufacturers, perhaps the conveyor, putting all those systems together is actually quite complex and requires a lot of engineering hours to make the system works. Vention approach has always been to Legoify or build building blocks that can be reused to create automation quite simply, both on the software side and hardware side. So today we have a pretty exhaustive platform with around 3,000 Lego bricks or industrial Lego bricks, including robots, end-of-arm toolings, but also software to design those robot cells, program them, simulate them with our clients ahead of capital expenditure, and obviously deploy them and operate them later. So with that approach, we're able to simplify greatly industrial automation, make it more accessible, and more importantly, make it significantly cheaper than, again, traditional technology. So that's, that Lego approach that characterized Vention, that's how we were able to go serve small, medium businesses. So a manufacturer that would be interested will simply go on the Vention website, look for the Vention sending solution. And from there, we will try to work with them to understand the process, understand if he needs a sending cell that needs a 1-table or 2-table configuration, the type of material you want to send, the type of typical SKUs that it would see, the type of mix, and we would design the last mile with that clients online, and we offer those consulting services for free, and we get to a fully configured system usually within a couple of days. And after that, a system like the one we've talked about today is usually deployed in a matter of 3 to 5 weeks. So it's a pretty rapid cycle, again, because we keep leveraging those building blocks.
So now Vention is what you're really selling is the setup and integration of these, as you call them, Lego systems. And then as far as the machinery, you're not manufacturing robots or anything like that. You're subcontracting with other folks, I would assume, to supply the equipment and all.
We offer a full turnkey offering, from the initial helping our client define the right scope for their problems or their manufacturing. A lot of clients we work with are just starting their industrial automation journey. So there's a lot of question, there's a lot of education needed, and we're offered that up to the deployment and the operator training in their facilities. The difference will be in the fact that we use Lego bricks. So Vention is a manufacturers of those Lego brick, but we also have injected a lot of partners in our ecosystem, including Fennec, which is the primary robot partners that we have for this application. So the application is based on a Fennec CRX, which is a very rigid robot for sanding, and we've integrated obviously 3M abrasive for that product. So we have all those building blocks that are meant to go with one another. So leveraging our own manufacturing capacities for those building block and the expertise of others like Fennec and 3M, we can have Lego-like solution that can be deployed very quickly, turnkey.
Wow, that's great, because I think particularly in the sanding, most of the shops that I talk to, they'll tell you that their biggest bottleneck is in their finishing department. But when you really look at it, it's probably in the sanding. and if they could, fix that, of course, then the bottleneck will move somewhere else. But
and let me perhaps share a story here, William. We had client coming to us in our automation business, telling us that we're trying to automate this and that process, and we had so much demand for automating this, and we did project with those clients. It's time to productize. So we've done enough cases. Let's create a product that can be deployed at client repeatedly with the same quality. And that's where, we reached to 3M Invention, started to work together to bring that products to market. But the need came from client that felt that pain, that need to automate the last mile, couldn't get productized solution. And after doing a couple projects with our own Lego bricks, we decided let's go even further and let's productize something that can be deployed repeatedly. And that's where the relationship with 3M emerged.
Oh, that's great. Now, folks, you said they should go to your website. What's the URL for your website?
Vention.io. And from there, I encourage the auditors to go on the application menu, and you will see sending. And from there, you can see all the offering. If you click a contact to an automation expert, you'll be connected to somebody who has expertise in sending, understand also the abrasive technology of 3M pretty well, and we can start the discussion from there.
That sounds great. Well, I definitely would love to visit one of your plants where this has been put into place. It would be a great story to see how it actually works in person. So one of these days I'll have to connect with you on that. But I think this is some great information to get our audience started on this. I think definitely robotics, it's not the future, it's here now.
Definitely here now. It's a very actually mature and repeatable application.
Well, thank you much, Etienne. Go ahead, Nick.
No, it is, and it's growing quickly in many industries, and Vention is making it possible and easy to deploy in the woodworking and cabinet industry today.
Well, that's great. Well, thank you both, and I enjoyed hearing about this, and I'm sure we'll have you back another time to talk some more about this. Thank you very much. That's it for today. If you're looking for more of our podcasts, you can find all of them at woodworkingnetwork.com/podcasts and in popular podcast channels. Be sure to subscribe so you don't miss a single episode. Thanks again to today's sponsor, FDMC Magazine. To learn more about Vention, visit their website, which is Vention, like invention.io. That's VENTION.io. If you have a comment or topic you'd like us to explore, contact me at will.sampson@woodworkingnetwork.com. Thanks for listening.